All right, so step 5 is T for test statistic. And so we start with the statistic from the sample data. And since we're dealing with qualitative data, that's going to be p hat, so our sample proportion. So p hat, formula for that is x out of n. So they had told us 51 out of 14,495 of these prisoners had died, which if we compute that on the calculator, that comes out to be about 0.003518. Well, and from that statistic we can make kind of like what we call a standardized statistic, a test statistic, so the z-score. So for the z-score, we're going to compute the distance between p hat and p0. So we're going to take p hat minus p0, and then we're going to divide that by the standard deviation, which in this case is p0, 1 minus p0, all over n and the square root of that entire quantity. So if we plug in the specific values from this problem, for p hat we had 51 over 14,495 minus, and p0 was 0.0027, all over the square root of p0, which is 0027, 1 minus 0.0027, and that whole product over little n, which was 14,495. And again, we need to make sure that we take the square root of that entire denominator. And again, we can key punch through this value, or after we do the test, we can kind of cheat and write the value that we're going to get on that output screen. So if we actually compute this value up here, we would get a value when we round it off to be about 1.89. Okay, so it will be this value that we see next to the z-score when we do the one proportion test on the calculator. Okay, so this number, z-score, if we go back to the first unit when we talked about z-scores, this means that our observed, what we actually saw in the data, sample proportion, is about 1. Well, I guess if we actually round that, this would actually be 1.90. So this is about 1.90 standard deviations above, since it came out positive, the claimed population proportion. Okay, so the gap's about 2 standard deviations. But again, we mentioned before, common people don't really know what we're talking about when we talk about standard deviations, and so we translate that into a probability with a p-value. So the next letter in Phantoms is O, which stands for obtain the p-value. And then we're going to make a picture to make some sense out of all of these numbers. So on the TI-84, you would go to the stats screen and right arrow over to tests, and then next to choice 5 you'll see one proportion z-test. On that input screen next to p0 we're going to put in 0.0027 from the hypotheses. X and n are from our sample data, so that was 51 and 14,495. And then for our proportion piece here, this is what we need to look next to our alternative hypothesis. And that we were testing that the proportion was greater than this 0.0027 number, so we're going to highlight greater than p0 here. And then on the output screen, the first thing that you should check on this output screen, just to make sure inequality symbols are going the correct way, is to check the first line up here and make sure that it matches what you have written on your sheet for the alternative hypothesis, which it does. And then the numbers on here, here's our z-score that we set up the formula up above for. Again, rounds to about 1.90. Here where it says p, that is not p. That is really the p-value. So we need to make sure that we write that all out, where that p stands for probability. And on the picture, it's going to be our tail probability. So this is not the value of p from the hypothesis. And then here's our p-hat, so there's the number we computed earlier when we took x divided by n, and our sample size is given there as well. So our p-value here, if we round off, is about 0.0288 if we keep 4 decimal places. So we've all heard the expression, a picture is worth 1,000 words, and it really is here in statistics as we look at the sampling distribution. So in this case we're using a normal distribution, so we start here with a normal curve. We've got two set of axes down here, the set of axes for our random variable p hat, and then our test statistics. Since we're running a one proportion z-test, we're also going to have our standardized z-scores down here. So the hypothesized value of p hat, so again, in the center here goes the claimed value. So in the null hypothesis, they claimed our value of p would be 0.0027, so we would expect to get a value of p hat near 0.0027. The z-score, so how many standard deviations away from center are we here? Well, we're standing right on center, so our z-score would be 0. Okay. In our data, our p hat value rounded was about 0.0035. Its corresponding z-score was 1.89, so these two scores go directly above and under each other because they correspond together. And then it was a right tail test, so we're going to shade to the right of those values. And then the p-value, again, the p-value is that tail probability, or that shaded tail area. So this shaded tail area here is 0.0288. And then we were asked to compare that. They gave us an alpha value of 0.05. So either that's less than or equal to 0.05, or it's greater than 0.05. And in this case, okay, 0.0288 is less than or equal to 0.05, which means we have an unusually high value, which means we're going to reject HO and conclude that the parameter is higher than what they've claimed. So our next step here is to make a decision. So since our p-value was less than or equal to this value of alpha they gave us, 0.05, we reject HO. We don't think that claimed value of the parameter is correct. And so our last step here, the last letter in phantoms, is an S, and that's where we're going to state our conclusion in context. And so if we reject HO, that means that there is significant evidence to conclude HA. So in this case, we're going to say there is significant evidence to conclude that the proportion of deaths of all Aboriginal prisoners is more than, that's what our alternative hypothesis said, it had greater than symbol, is more than that 0.27%, but remember that was the number we were comparing against because that was what it was for the non-Aboriginal prisoners. So we're just going to put that context in here as well. So is more than that for all non-Aboriginal prisoners.